I've spent the last 2 days being violently ill, so yeah, it was terrible. You guys want to hear the story, or do you not care for it? Give me a thumbs up if you'd like to hear the story. Okay, that's more thumbs up than there would be thumbs down. This is the story, all right? So, Sunday, morale was kind of low, so we decided to go out, get some meat. We got some steaks. It was only like 7 degrees outside, but I fired up the barbecue. I made us some nice medium rare steaks. And I know what you're thinking, but it wasn't the steaks. It was, in fact, the barbecue sauce. Because it was barbecue sauce from the previous summer that was still in the fridge. And normally you'd be okay if it was like Kraft barbecue sauce or one of the other highly processed barbecue sauces, because how long does ketchup take to go bad, right? And barbecue sauce is basically ketchup with extra spices, right? But it wasn't. It wasn't that. It was like some independent, fancy indie barbecue sauce, right? So I have some. Thank God my wife and child didn't, because holy shit. Anyway, long story short, basically my entire digestive system was liquefied, including half of my other organs. Fortunately, the ones where I had 2 of them anyways. And then had to be violently expelled from both ends. And it took a couple of days to recover from that. Basically I spent the entirety of Monday just a puddle of goo on the couch, moaning and whimpering intermittently while watching Seinfeld, which they've now put on Netflix. I wasn't even well enough to play video games. That's how bad it was. Everybody knows what I'm talking about. So yeah, so that's how I spent the last couple of days. So I apologize that there was no lecture Monday. I have no intention to make it up at this point. I don't know if that's useful. We'll call it a snow day, I guess. Or you should have known better than to eat that barbecue sauce day. But anyway, so that's that. If I'm still a little bit, not my usual perky self, that's the reasons, because I'm still, I'm still reconstructing my liver. So anyway, we were talking about structured query language, databasing in general. Good. So, this thing on? Have I been? There we go. Blah. There we go. Slightly better. So, last time we kind of only went over the very bare bones basics of what a database even is. I've been encouraging you guys so far to use a rough correspondence with spreadsheets, just to get yourselves into the concept. Databases are capable of a lot more than spreadsheets are, and you interact with them in a very different fashion from spreadsheets. Like, if you take the concept of a spreadsheet and kind of apply it to a command line interface or a command interface rather than the GUI, that's GUI, graphical user interface, then you're approaching the correct conception of a database. So, through this unit, we'll be developing a video rental store example, which we'll go into some deep depth today. Basically, inside of a database, data is grouped in 3 ways: into tables, fields, and records. Tables are approximate to the sheets in a spreadsheet application. Fields are approximate to the different columns in a spreadsheet application, and records are the rows, at least if you use the kind of traditional spreadsheet configuration the nice thing about a spreadsheet is if you really want to, you can put like records in as columns and the rows in as, or the fields in as you know, rows if you want to. You can, you know, what's called that, a transpose matrix. You can do that if you want to, but generally you don't because, you know, the way the data is written is usually more amenable to the other way around, but I digress. So at some point we'll be entering that into an actual spread or an actual database application this today. So in order to set a database up, in order to set a database table up, unlike most things in Python, and unlike even your conventional spreadsheets, you have to know what your fields are up front, or at least you should have a reasonably complete idea of what your fields are up front, and you should know what specific data types should be attached to each. Unlike a spreadsheet, a database is strict about its data types. You know, with a spreadsheet, you can have a formula in one cell of a column, an actual value in another. The spreadsheet isn't going to complain to you about that. In a database, that's not the case. If you try to put something where it doesn't belong, it will complain at you and prevent you from doing so. Incidentally, as far as we are going to go with databases, we're not going to cover a concept analogous to putting a formula into a cell. That's not something where that would be like advanced databasing, and this is the most basic databasing. So, among the valid types that you'll have in pretty much any SQL distribution, integers, reals, note that real is the same thing as float, 8 bytes, so 64-bit, right? Text is essentially, that's Unicode versions of strings. There we go. Booleans, of course, and dates, which are stored as a numeric value, although that does depend on the system. So, in our example of movies, of course, title, genre, and rating are all encoded as text, whereas the movie ID is encoded numerically as an integer. So, now that we know, we have some idea of what we're talking about here, let's talk about the actual software itself. So, structured query language is we talked about this last time, but it's still very highly and widely used, despite the fact that, you know, certain new, fresh competitors on the scene have been, you know, getting their sharp elbows out, trying to take some of the market share. SQL was first proposed in 1974 for Codd's relational database model, which dates from 1970. So, just for context, SQL dates from around the same period. It's kind of like shortly after the release of C, the C programming language, and shortly before the release of C++. It's kind of in that interregnum. The 70s was a fantastic time to be a computer scientist. It was like being a physicist in the 1700s. But anyway. So the whole idea with the relational data, this database model that SQL uses, is you've got the data off to the side. You interact with that data through a command line interface, you know, similar to the Unix command line interface that had recently become popular. The syntax is mostly independent of the vendor. And at this point, we're going to have a discussion of the difference between the language and the vendors of that language. And this basically follows the proprietary software model that was being used in the 1970s at the time, which of course was derived from similar models that were seen across related fields like electrical engineering. So this is how software used to be developed back in the 70s, right? You would have a company or foundation, or probably Bell Labs, develop a specification for a language. Take, for example, the C programming language. You would have people develop a specification for that language. That language specification would then be licensed by vendors, right? So if you know anything about the C programming language, you know that there are several implementations of the C compiler, right? The biggest one, and the one that you're most likely to use or have heard of, is GCC, which stands for the GNU Compiler Collection, right? A compiler that you will be using you'll become quite intimately familiar with if you happen to be taking 1xC3 in the summer, which I just happen to be teaching. So I got my contract yesterday, so I'll be teaching it. So everybody sign up right now. Anyway, there's still 80 slots left in the class, according to Mosaic anyway. But anyway, so GCC, that's one implementation of the C compiler, which is maintained by the Unix Foundation or the GNU people or whoever those mysterious people are that maintain Unix. In addition, there's a couple of other ones that are big. One of which is Clang, which is IBM's implementation, I believe. Clang stands for C language. Independently maintained, right? But both GCC and Clang implement the C standard, right? Both are independent implementations of the same standard, right? So the idea, back in the heady, highly capitalistic days of the 1970s, is that these independent vendors would come up with their own versions of the their own implementations of the language, and whichever one was the more virtuous, as determined by market forces, would eventually beat out and take over the other one, and consume the majority of the market share, which it turned out in this case was GCC, although that was aided to a very great degree by the popularity of the Unix operating system, which was distributed for free to universities, which is why it became so popular. So whether it was market forces that made GCC so so popular, I think you could make a pretty strong argument that it wasn't. But at any rate, so essentially, both of these implementations of the C language are implementations insofar as they follow the C standard, right? Now, the thing that differentiated the C standard from a lot of other standards at the time was that it was very strict, right? It had definitions for just about everything. There was not much room for interpretation in the C standard. That's why a C program written for Clang and a C program written for GCC are mostly interchangeable, like they can be cross-compiled by the different compilers, right? There is a little bit of a catch there, because some things which GCC considers compiler warnings are compiler errors in Clang. So it doesn't, not everything will quite compile, but mostly the crossover is there. And they're like, okay, sure, this is all about the C language, which we know is one of your personally beloved languages, but what about the thing we're actually talking about? So SQL was originally, and in fact still to this day, is distributed by the same model. You have the SQL standard, right? And then you have SQL vendors. The difference between SQL and C is that SQL was defined with far less rigor in terms of its original specification. There was a lot more room for interpretation in the SQL standard than in the C standard. As a result of this, different companies were able, to a much greater degree, to differentiate their differing implementations of SQL by including different features. Right? While all SQL implementations must contain some common set of features as specified by the original specification documents, past that point, your ability to use a particular vendor's SQL implementation will be dependent on your knowledge of that particular implementation. Make sense? Any questions about that? Okay. So, yes. In addition to the regular databasing stuff that we are going to be covering, SQL also supports some repository-like functions, such as commits and rollbacks, authorization. You can store functions as well. If you take the fact that you can make the results of one SQL query the input of, you can make the output of one query the input of another. That is to say, you can pipeline queries together. You can actually develop SQL into a full programming language, right? Now, you know, computer scientists such as myself have a particular definition of what it means to be a full programming language. When you hear somebody like me say that, what we mean is it's Turing complete, right? I've discussed Turing completeness in this class. Nah? Don't remember? Okay, well, I'm not going to go through the full spiel today, but essentially what it means for something to be Turing complete is that you've got if statements and while loops, the ability to produce a non-terminating program, and that essentially, like if you meet those three conditions, you can demonstrate mathematically that this program can be expressed as an equivalent Turing machine, right? You guys, we did Turing machines, surely, right? No? Well, go watch a computer file video then. I'm sure there's a good one. But anyway, the thing that's interesting about the property of Turing completeness is that any program which is expressible in a Turing complete language can be expressed in any other Turing complete language, right? So any Python program can be written as an SQL program. The question is, how convenient is it to do so, right? Always select the best tool for the job, right? Anyway, recently, no SQL databases for storing differently structured data and cloud storage are becoming popular. A lot of these are following JSON formats, as discussed previously. Any questions? Okay. So, there are many different SQL database applications available for your download purchase. Some of them are free, some of them are not. Commercially, we have things like Oracle, Microsoft SQL Server, or what do they call it? The one that's bundled with Office. Is it called Access? Microsoft Access, yeah. In terms of open source, you have MySQL, MariaDB, PostgreSQL, SQLite, MongoDB. Mongo is one of these non-SQL databases. Apparently David doesn't like it.
He doesn't?
Yeah. He's like, I don't care for it. So, the one that we're going to be focusing on here is SQLite. So it's what you might call a lightweight implementation of SQL that is suitable for educational purposes because it doesn't, it doesn't require a lot from your system, and you don't have to set up any servers if you use, it's like databasing but on local files, whereas a lot of these guys you have to like set up a web server and pay for a domain name and all that kind of stuff, which is well beyond what we want to cover in this class. So that's 1xd3 if you're interested in that kind of stuff. So yes, most use SQL, and we will use SQLite in this course. Good. So SQLite then. SQLite is a widely used serverless relational database manager. So you can interact with it pretty much the same as you can interact with the kinds that you would have to log into remotely. However, it's serverless. That means that the database file is stored directly and locally inside of your file system. Similar to any other type of file that you would normally use. You don't have to run any additional background services. For example, in order to run it locally, you don't have to have your computer running a local host, like emulating the fact that it's accessing a network. It just interacts with the file. It's not efficient for large databases or multiple users, but it is good for just, personal use or to learn SQL. It'll be pre-installed on Macs and some Linux distributions, as well as with Python, or you can download it from sqlite.org. Let's see, do we have a slide on, okay. Uh-oh. Yeah, okay. No, not my email. Not that. Okay. sqlite.org. There we go. So this is sqlite.org. This is like, if you're paying attention out there on the internet, this is the very, very important part where I show you how to get the software you need. And that applies to all of you guys as well. So if you happen to have the misfortune of using a Windows-based operating system, this will be how you get it. Go to download, download. Oh my God, come on. Don't leave me hanging. It's not even doing the look. There we go. All right. So what you're looking for are the pre-compiled binaries for Windows, because who wants to bother compiling this stuff? You want to go with SQLite tools. Do they have the 64-bit version here, or is it just the 32-bit version? Whatever. SQLite tools, Win32x86 version number. A bundle of command line tools for managing SQLite database files, including the command line shell program, which is what you want. All right? Including a diff file and an analyzer. So you will get, if you download this package and extract the compressed archive, you will receive 3 executable files, one of which is the command line shell program, which should be called sqlite3.exe or something similar. And if you double click on that, it should, under normal circumstances, bring up something that looks like your DOS prompt, right? Has anybody been following along with that? Does anybody manage to get it working? Is it working? Sorry? Pop up that says what? Oh yeah, you need to extract all, for sure. Yeah, you can't. You have to extract. You have to decompress the archive before you can run anything in it. It might also. There we go. Awesome. Thank you. So it's it might gripe at you that you're like running an executable from the internet, but you know, if a virus wrecks your computer, build a university, okay? Anyway, because I'm cool and I run Linux, I can just run it straight from terminal. Sqlite 3. There we go. Actually, I'm going to run that from a folder that makes sense for this course, teaching 1MD3. Samples. All right, Sqlite 3. There we go. So Sqlite is a command prompt interface in the same way that you know, this Linux bash stuff that I've been showing you guys throughout the semester is also a command line interface. So in order to actually save this stuff to a file, you have to open file name. So let's .open videostore.db. Traditional file extension for a database file is .db, as you might expect. Linux expects that, which is why, if we take a look at the little icon, it should, oh, it didn't, oh, that's a shame. Often the symbol that you'll find for a database is a bunch of stacked cylinders, which is actually supposed to represent your hard drive. That's like the symbol that you'll often see for database software, or database data. Anyway, not important. Moving on. So, good. So, now that we have a database open, let's see how we interact with it. Obviously, the first thing that we need to do is create a table. Database files, when opened, contain literally nothing. You have to put everything in them yourself. So, create table. The command to create a table is, of course, create table. The next argument is the name of the table you're creating. You then, in parentheses, provide the schema that we discussed previously, right? The schema is a comma-separated list of all of the field names associated with their data types. I know that you guys are all Python programmers at this point, and the idea of including data types along with a list of arguments isn't immediately, you know, not your immediate reflex, but that's a reflex that you should consider developing. So, .tables, nothing. Create. Incidentally, one thing of note. In SQL, keywords can either be all caps or no caps, right? So you may see me use no caps on the terminal, and then, but the thing it's referring to is in all caps. Throughout this set of slides, keywords have been identified separately by the use of all caps. So that's how we're distinguishing those things which are keywords from those things which aren't, because SQL, as it turns out, is a reasonably verbose language, and it may not be distinct what's a keyword and what's a field. So that's how we're going to distinguish them. Just understand that distinction, you know, it doesn't have to be made using all caps, right? Cool. So, there we go. So, create table, movies. No. Okay. So, interesting thing about entering things into this prompt. If you press enter without having pressed a semicolon, it does not consider the command to have been fully requested. So it'll give you another line on which to enter it, and if you just continue typing as if nothing happened, basically everything will be fine. So, movie ID, integer, title, text, genre, text, rating, text. So before I press enter on this, let's just discuss a couple of different interesting variations that we can have on the data that we're entering in here. So, number one, I'm going to start with this one. In the same way that in a spreadsheet, you can leave an entry blank, right? In a database, you can leave a field blank in a record unless that field has been designated as required. So essentially, if you put the required keyword inside the list of arguments when you're creating the database, that will constrain the database such that for every record, if the field is not presented, that record is not added. It's considered to be an error or a, you done goofed. That's a you done goofed state. So that's number one. You can require certain fields to be filled out. Number two, primary keys. So it will often happen with pieces of data that certain pieces of data must be unique inside of your database. Things like, if you were the government, social insurance number, right? No two citizens of the country should have the same social insurance number for obvious reasons, right? If that does happen, it's a crime, right? Crime strictly defined. Although probably not punished to the same degree because that would be a blue-collar crime rather than a violent crime, but still crime. Crime bad. Anyway, in our context, even if we have multiple copies of the same movie, right, it will often happen if anybody actually remembers video rental stores, even if a video rental store had multiple copies of the same movie, each copy would have a different ID number so that which copy was loaned would be known, right? So in our case, in our movie rentals database, each movie must have a unique identification number. So the primary key field, like a field which has been tagged as a primary key, must have unique values. This is most often associated with integers, but it can be associated with other things, I suppose, if you want. Yes, it is useful to have a primary key to cross-reference tables. Yes. Any questions about that so far? This is all reasonable, right? This shouldn't be blowing anybody's brains apart. Right? Yeah. So, if we add that fact to the query that we've got queued up here, right? We should say, perhaps, it is reasonable that the movie ID should be a primary key because we've already sort of identified this as being a unique identification number, right? So we'll make that a primary key. And this is one thing about SQL that kind of throws people off sometimes is like multi-word keywords. You can have multi-word keywords in SQL. Again, I'll try not to make this into another one of Professor Moore's pet peeves about programming languages session. But anyway, it is reasonable that any movie should have a title, right? Though a movie may defy genre and may not be rated, it may not even be in such a rated state that the ratings authorities recognize it as being not rated, if that makes sense. That movie will still have a title in most cases, unless it's like some kind of, Eldritch Halloween prank or something, the untitled movie, or something like that. But even these sorts of things tend to have titles. So it makes sense to make the title required, because if a person fails to enter a title, that is most likely a mistake on the part of the person entering the data. And one thing that you absolutely want to do is never trust the person entering the data as far as it's possible to not trust them. Because data entry is the worst, it is among the worst possible jobs. It's just you sitting at a computer, repeatedly entering the same fields for 10,000 things that you're trying to enter. Data entry sucks, and if you get a job doing exclusively data entry in the future, try to bear with it until you can find a better job, because you may have to, but otherwise, just promise me you won't do it for the rest of your life, because you will become, old and bitter at the age of 32. And anyway, so, movie integer primary key. All of the data entry people who watch this on YouTube, please leave me an angry comment. I love data entry. Data entry is the best part of my job. It's like, wow, I hate to have the rest of your job. I don't know, you think anybody would be sufficiently, I don't know if anybody would actually defend data entry as being enjoyable. But anyway. So, we press enter. Must include semicolon at end of statement. Just like all programming languages that are, that matter or are Haskell, you must include a semicolon at the end of statement. You don't do that in Haskell. I was trying to include it in languages. Anyway, so we go dot tables. Dot table, we can see that the movies table has been added, although it is currently blank. Make sense? So the question then becomes, how do we populate this newly created table with data from our data that we are trying to enter? It is with the insert command. Insert into, you specify the name of the table you're inserting the information into. You then include in parentheses, well, this is optional actually, if you're entering all the data. We'll get into it. Yeah, it's insert into movies. You can provide the schema, right? This is optional actually. Then you provide values, and then you provide a comma delimited list of the values you wish to enter in the same way that you would provide arguments to a function in Python. So let's try it out. Insert into movies. Movie ID. Title. Genre. Rating. Values. 101. Casablanca. Drama, romance. Partially garbage. Oh. Yeah. Oh, that's just a weird character because I pressed up or something.
Do you double quotes or does it have to be single quotes?
Either is acceptable.
Okay.
Yeah. The question was, does it have to be single quotes or are double quotes acceptable? The answer is either is fine. Good. So if we, I'll just give it away. The way that you view stuff out of the database is select star from movies or whatever the table is, and that shows you the entire contents of the table. So you can see our entry has been populated. So, just to demonstrate that it works, we can also omit the recapitulation of the schema. You can also, in these types of interfaces, if you didn't know this, you can press up and down to scroll through previous commands that you've entered. So let's just do the next one. So you don't have to retype the whole thing each time. Back to the qqorg. Delete. It's a comedy adventure. Sure, we'll call it that. There we go. And you can see it's in there as well. In the same manner, despite the fact the schema has been left out. Yes?
Are we allowed duplicates in the table?
Not if you've got a primary key.
Okay.
The primary, okay, let me show you. If I try to enter the same thing again, error, unique constraint failed on movies.movieid. When that happens, that entry is not added, right? So you could have two movies in the database that were both Back to the Future, but you would need them to have different ID numbers, which would, in real life, that would indicate you have two copies of Back to the Future.
Do you need a primary key when we're setting up the table? Or,
No.
So if there's no primary key, we could.
Yeah.
Okay.
Yeah, the primary key is at your discretion as the designer of the database. Assuming that you have the liberty of designing the database, which is probably not something that you would ever have on an exam question. For example, you would be implementing a design that was given to you in the question. Or working on a database that had a design that was done by a TA. Anyway, yes, good questions. Any other questions? Good. So let me show you why you might want to, right? So let's say we had, movie number, let me find a unique one here, 105. We'll call it, what's a movie? Anybody? The Imitation Game. Ooh, good one. On point. The Imitation Game. Let's just say that we did not want to make a decision about what its genre is, and we just wanted to give the rating. We wanted to leave the genre part blank, but still provide a rating. If we do it like this, it'll assume, I think, probably, PG is a rating, or is a genre rather than a rating, because it'll go in order, right? But if you want to leave a 0 in the middle, that's when you need to reprovide the schema. But the schema as applied to the values which are provided. So, movie ID, comma, title, comma, rating. Boom. No errors. Always a good sign. And you can see, in the, at least in the text interface, the way that shows up, the Imitation Game, nothing, PG. So this spot is intentionally left blank. Make sense? Good. Yeah. Good. Very good. So, I think that's everything there. So, oh, sorry, question? No, it would insert an empty string, and an empty string is different from a null value. So, not quite the same thing. Although, you could definitely design the thing so that it was looking for empty strings as if they were nothing, right? But, yeah, not quite the same thing. Yeah.
Wait, so what's in that empty space? Is it a null or an empty string?
It's a null
It's a
value.
null, okay.
Yeah, that's a null value. Any other questions? Okay. Good. So, I'd like you to consider now a situation. Let's say we have a nice, cute little database here going, very, very small, let's say you had, 10,000 movies, right? And you had to find something in this database of 10,000 movies, right? This is where SQL starts to pull away from spreadsheets and start being useful, right? Because up to now, all we've done is worse command line spreadsheet with no functions and no pretty formatting and no graphs, right? Now, we start seeing how spreadsheets can actually be applied to large data sets to be useful. However, it requires you to use a little bit of imagination and imagine a much larger database than the one we currently have. So, first, we can be selective about the fields that we want to see. When we say star from movies, the star here is a wildcard character. This represents all fields, right? That's what star means. We can actually narrow down on just the fields that we want to see by specifying them. So movie, ID, and rating. So we can see just, sorry. I forgot the thing I thought I was going to remember. Boom, there we go. So you can see just those two fields represented. Okay, sure. We can also filter our results by various Boolean conditions, right? These Boolean conditions function pretty much exactly like the Boolean conditions that you're used to in if conditionals and while loops that you've been using so far in the course. This is where databasing starts to look more like programming and less like your household budget spreadsheet. So, for example, if I wanted to say select movie ID and rating from movies where the where clause specifies the beginning of a Boolean condition, where, let's say, I wonder if that'll work, where genre equals null. Nope. Okay. That won't work. Where genre is equal to comedy adventure. And then you just get the specific one that matches that query. Make sense? Any questions? Good. So it turns out that this this is a very important construct to become familiar with. This filtering mechanism is not only used by the display mechanism, but it's also used by the update mechanism. So if you need to change the value of an existing record, you must specify the records to be changed according to a where pattern. That is why unique identifiers are useful in SQL databases, because that gives you a one-stop shop for determining uniqueness among all of your registered entries, right? Otherwise, you have to, piece together uniqueness from, however many fields, which is just painful. Good. So, in addition, you can, yeah, okay. I don't know. Do you think we have time for fuzzy matching? No? Yeah. Everybody just want to get out of here? Yeah. Okay. I think we can call class a minute early. Thank you very much, everybody. See you on Friday.